All right, here we're on section 10.6 on equations involving radical expressions. So our objectives are solving radical equations, deriving and applying the distance formula, and finally solving equations of the form x to the n equals k. So the power rule for solving equations. If each side of an equation is raised to the same positive integer power, then any solutions to the given equation are among the solutions to the new equation. That is, the solutions to the equation a equals b are among the solutions to a to the n equals b to the n. And so sometimes we'll have to raise both sides to a power 2 to get rid of a square root, or power 3 to get rid of the cubed root, and that's going to give us the same solutions no matter if we've already cubed it or if it was the original equation. Now the key is we always go back and check to make sure it is a solution. All right, so for example, let's solve this equation. And what we're going to do is we have to first isolate the radical. So the first thing we're going to do is going to divide by 4. When we divide by 4, we end up with this. Now this is where what we were talking about earlier, if we square both sides here, we can do it. What happens is that radical's gone, and over here we just get 9. And so that's what we do here. We get 9, subtract 1, we get 8, divide by 2, we get 4. And so our solution says it's going to be 4. Now what we're going to do is we're going to go check and plug it back into the original. So we'll have 4 times 2 times 4 plus 1 equals 12. Well, that's going to be 9. Square root of 9 is 3. 3 times 4 is, guess what? It's 12. So it does work. Okay. And that's why we have this. So this is our original equation. Then we solve for the radicand on one side, everything else on the other side. And then we can square both sides. Say if this had been a cubed root here, then we could cube both sides. And it doesn't matter. We're going to get the solution. And it should check back when we go back into the original. All right. So isolate a radical term on one side of the equation. That's step one. Then apply the power rule by raising each side of the equation to the power equal to the index of the isolated radical term. So like I said, square root 2, cube root 3, fourth root 4. Then we solve the equation. Now, if it still contains a radical, repeat steps 1 and 2. Sometimes that happens because you're going to have multiple radicals. And then final thing is always check your answer by substituting each result in the given equation at the beginning. Don't do it in any equation below that. Do it at the very beginning equation. All right, so first things first here. If we have this, we need to isolate the piece over here. We need to get this piece by itself. So what do we need to do? Well, we need to take that 3 over. So we're going to add 3. Okay. And so if we do that, we get 4. Now we can go ahead and we have a square root and a 4, so we can square both sides. And when we do that, the square root drops. We get 6 minus x equals 16. Now we solve for x. Now what we can do is we can subtract the 6 and get minus x equals minus 10, or x equals 10, negative 10. Okay. So that, I don't know what I was saying there. So we subtract that, we get 10. Then minus that is going to be the minus 10. Okay. Now, what we need to do is check and see if that works in here. So going back into our original equation, plug in a negative 10. 6 plus 10 is 16. Square root of 16 is 4. Minus 3 is 1. And it checks. Okay, so that means the solution is x equals negative 10. All right, let's pause there and come back for some more.